And why should you learn rational functions? Rational functions are used to model and solve many problems in the business world. Like some of the examples of real-world scenarios are average speed over distance for traffic engineers, concentration of a mixture for chemistry, average sales over time, average cost over time as well. Can you think of any rational functions that we have been working with and that you might use? What is a rational number? It's a number that can be expressed as a fraction. So what is an irrational number? A number that cannot be expressed as a fraction. Pi, radical 2, Euler's number. Rational function has the form where you have a polynomial over another polynomial. The parent function is 1 over x. And the graph looks like this. The graph is not continuous and has asymptotes both vertically and horizontally, as shown by the red lines. Notice that in this case, we have no transformation and the asymptotes are actually the x and y axes. So y is equal to 0 and x is equal to 0. Okay, so if we have the parent function, please remember that we could show the transformation as a 1 over x minus h plus k. Remember, a does a vertical stretch or shrink, h moves the graph left and right, and k moves the graph up for positive or down for negative. Okay, so how does this move if all of a sudden I put a 1 over x plus 3? That is correct. What happened is the horizontal asymptote moved up 3. Notice the yellow line. Okay. The horizontal or the vertical asymptote is still in the same place along the y-axis for x equals 0. All right. Let's take a look at this graph. How does this move? All right, you are correct. Okay. Notice the 3 is with the x, leading to a left-right horizontal transformation. In this case, a positive 3 moves the function to the left. And what about this function? Notice, tell me, you are correct. In this case, notice that we had a vertical movement down by a -4 for our horizontal asymptote to be at -4. And then the horizontal movement right by 2 because -2 moves the function to the right. Oh my, how does this move? 1 over x squared. Notice, because the x squared is in the denominator, there are no negative y values. Thus, the shape of the graph changes a little, and the negative part that was in the third quadrant is flipped over the x-axis, and now it's in the second quadrant, okay? Alrighty, can anybody tell me on the second graph, what was our transformation? That's right, it transformed up 2. What about this transformation by the graph? What happened here? That's right, it moved to the right 3. What about this transformation? All right, so yes, so in this case, we moved up 4 and then we moved to the right 3. Okay, Let's take a look at the domain. The domain is determined by the denominator. Set the denominator equal to 0 and solve for x. What's going to be our x value for x plus 2? Okay, think. What numbers can I put in for x? The denominator can't equal 0. It is undefined there. Okay, our x value is going to be -2, but if I put in a -2, you can see that the denominator is going to become 0, which is undefined. So that means that I can take any number from -infinity to -2, and I union that with a -2 to infinity. Find the domain, set the denominator equal to 0, and solve for x. Okay? In this case, the denominator can't equal 0, but please notice that even if you put in negative numbers, so we're always going to turn positive. So we are okay here. This domain goes from -infinity to infinity. We would have had an imaginary number if I had tried to take the square root of -1. There's no numbers that makes the denominator 0. All right, so the denominator can't equal 0, but which x values are going to make the denominator equal 0 here? That's right, it's -1 and -2. Okay, so notice that if you set your factors equal to 0, this goes all the way back to Unit 3 with our polynomial functions. Okay, so we have to take the parentheses, set them equal to 0, and solve for x. So notice that our domain is broken up, -infinity to -2, unioned with between -2 and -1, and then -1 to infinity. Okay. At the values for which the domain is undefined, there will be one or more vertical asymptotes. List the vertical asymptotes for the problem below. All right, what's going to be our vertical asymptote for this problem? That's correct, it's -2. What is our vertical asymptotes for this problem? That's right, it's -1 and -2. What are our vertical asymptotes here? That's right, we have none. Okay, here we have a graph of 1 over x plus 2. We're going to kind of look a little more in detail at what is happening as you approach the vertical asymptote of -2. Okay? See our vertical asymptote right there. Okay. So the line x is equal to a is a vertical asymptote of the graph of f of x if your y values approach infinity or -infinity. Remember, f of x is equal to y. So what the math's saying, if you set the denominator equal to 0 and solve for x equals asymptote, which is being called a, this a is not the same as the a for the transformation. Please remember that. So we're going to look at some tables. Notice this. I'm not going to ask any questions through this, but you can fill out your Google Doc. Okay? As x approaches -2, so notice our x's are approaching -2. We start at -3, -2.5, -2.1. Notice how large our f of x gets. When this is approaching from the left, notice how the f of x, the y values turn negative. Now let's approach it from the other side, -1, -1.5, -1.9. So as it approaches -2 from the right, notice how your f of x is now approaching infinity. They're just getting larger and larger. And so we're just looking at the y values for here. So you got -infinity down in here, and then you have infinity up here. Okay, so we know that x equals -2, you have a vertical asymptote. See that? Okay, so describe what's happening to this x and determine if the vertical asymptote exists, giving the following information. So now we're going to look here. Notice we're going from a -4 and we're approaching -3. Okay, so we're approaching -3 from the left, and notice that these values are getting smaller and smaller. Over here, we start at -2, and again, we're approaching -3, but these values, they're getting larger and larger. Okay, so -3, approaching from the right, and you have your y values are going to infinity. Okay, so we do have a vertical asymptote at x equals -3. So remember, solving for vertical asymptotes, you're setting the denominator equal to 0. You're substituting the x values into the numerator, and the values for which the numerator does not equal 0 are the vertical asymptotes. So here, notice that our domain would be between -2 union with 2 to infinity. Because we do have the vertical asymptote, it is going to be the 2, right? So notice how all of this goes together. Your vertical asymptotes are determining the domain, what is in the domain and what is not in the domain. Note, if you solve for the vertical asymptote, you get the domain and vice versa. Okay, so for here, we have to factor our denominator. So what is going to be our factors? Okay. And notice that you would set those equal to 0, and you would find that you had x cannot be -2 or 1. Okay, so we have vertical asymptotes at -2 and 1. So factoring, when you factor your denominators, that gives you your domain as well as your vertical asymptotes. Okay, so the graph of the function never crosses a vertical asymptote. All right. Notice the domain and the vertical asymptotes are x equals 2 and -1. That means the function crosses the vertical asymptote. That means that if the function crosses the vertical asymptote, then for some y value, x would have to equal 2 or -1, which would make the denominator 0, which is why that can't happen. All right, here goes a few problems for you to solve. Find the vertical asymptotes are found when the x's and the denominators are found. So sometimes you may have to factor. So for the first one, what would be our vertical asymptote? That's right. So our vertical asymptote is 2. Okay, what about B? What's our vertical asymptote? That is correct. We don't have a vertical asymptote. There will never be a -4 to cancel out the 4. All right, what are our factors for C, which turn into our vertical asymptotes? What are they? Okay, so you factor the denominator. We have x minus 2 and x plus 1. We set each to 0, so x is equal to 2 and x is equal to -1. So those are our vertical asymptotes. Okay. If you already have a factor, you just set each to 0, so our vertical asymptotes here are -3 and 2. Okay, what about the next one? That's right. Our factors are x minus 4, x plus 3. So that means our vertical asymptotes are going to be 4 and -3. And again, for the last one, the denominator is already factored. We set each one of those equal to 0, and x is equal to 2, x is equal to 1, and those are our asymptotes. Thank you for participating. The end.